Good afternoon, my geometry kiddos. Okay, we're going to continue our transformations chapter 4, by talking about rotations. Okay, so we've talked about two transformations thus far. We've talked about translations, which is more of a sliding motion. We've talked about reflections, which is a mirror motion. But today we're talking about rotations. Okay, rotations are exactly what you think. They are rotating something, turning something. Now, if we take a look at our definition of a rotation, we have some blanks that we want to be able to fill in. Okay, so a rotation is so we have a rotation, okay, is a transformation in which a figure is turned, okay, about a fixed point called the center of rotation. Okay, a rotation is a transformation in which a figure is turned. So this is a turning. Okay, it is turned about a fixed point called the center of rotation. Okay, for most of our examples, uh, you will essentially be using our center of rotation will be the origin of the graph. And that's 0.00 there. Okay. Most of our examples, the center of our rotation will be the origin, aka 0, 0. Okay. Okay, so in order to perform a rotation, you need to know three things. Okay, so you're going to need to know the center of rotation. Okay, so that's number one. You're going to need to know the direction you are rotating in. Okay, so the direction of rotation. And you need to know the angle of rotation. So how much you are rotating the figure or the image. So you need to know the center of rotation, the direction of rotation, and the angle of rotation. Okay. Now there are two directions of rotation. Okay. The first is you might already be familiar with them. You have clockwise and you have counterclockwise. Now, when you look at a clock, right, a clock normally moves this way. So starting at 12 here, we're moving this way around the clock. That is considered clockwise. Okay, so when our figure is moving in a clockwise rotation, it looks like something like that. So this is our clockwise rotation. Okay, so clockwise. Now, if it moves counter, so if your figure is moving toward the left here, this way, in a counterclockwise direction, so this is now where we have this guy here, this is called counterclockwise. Okay, it is called counterclockwise. All right, so one of these is actually the default direction. So if you are given directions on to rotate something, and they just tell you, rotate it 90 degrees, but they don't say clockwise or counterclockwise, one of these is actually a default rotational direction. And it's not what you think actually. It's counterclockwise is usually our default direction. So if a direction is not specified, then counterclockwise is our default direction. So if I did not have a direction specified here, and I asked you to rotate this a certain amount, you would have to take it counterclockwise, not clockwise. Okay. So we're going to do a little bit of discovery here with our lesson. And we have a figure here. Okay, I'm going to zoom in here. We have a figure here. We're given a quadrilateral ABCD. Okay, and we're going to use this quadrilateral to figure out how to fill in this chart here. So we want to write rules. Okay, we want to write rules for when we are rotating in certain directions and in certain degrees, because then that will help us actually be able to have rules just like we did with our reflection. It'll help us rotate our images that much faster. Okay. Now, one tool that I'm using is something that you can hopefully find in your kitchen somewhere, usually where baking stuff is held. So if we were in class, I would essentially pass out something called patty paper to you. And patty paper looks something like this. It's like a see-through paper. This is actually parchment paper that I got from my baking drawer, actually. So I got parchment paper and I cut it. You can see like over here with this one, you can see the perforated lines. I literally just cut out some parchment paper. This is like paper that you bake on. So if you've been taking Chef Doll's baking class, you might actually have some lying around. So I suggest that you pause the video and go cut some out for yourself. It's actually very helpful, especially with rotations, guys, especially with rotations. So what we're going to do is I'm actually going to trace my X and Y axis, okay, my X and Y axis, and I'm going to put my points here of my quadrilateral, and I'm going to mark my center as the origin. So for each one of these, we are going to rotate our figure a certain degrees, okay, and what that's going to do is by rotating the patty paper, it's going to allow me to see exactly where my points of A, B, C, and D land. Okay, so if I take a look here, we're going to first things first. Okay, we're rotating around the origin. So our center of rotation here, center of rotation is the origin. And then we have our direction and our angle of rotation here on our chart, okay? So first thing we want to do is we actually want to write the pre-image coordinates. So this is our pre-image quadrilateral ABCD, and we're going to write down these coordinates on our table so we can compare them to each rotated point. So A is going to be at 2 and 8. So that's 2, 8. Okay, let me zoom out a little bit. Okay, so that's 2, 8. B is going to be at 9 and 6. Okay, C is at 9 and 1. And finally, D is going to be at 2 and 1. Okay, so our general rule for these points, okay, our starting off rule, this is X comma Y. That's our XY. Okay, that's where we're starting at. Okay, so we're going to go ahead and take a moment and we're going to trace our, go ahead and take a moment and trace your X and your Y axes and your your quadrilateral here, marking the points clearly, okay? Okay, so I hope you guys pause the video there for a moment to trace this. I definitely did. So if you'll notice, I now have my figure with my graph, my axes. Here's my x-axis, my y-axis, and then I have my A, B, C, and D. So when I bring it and I line up my axes with the center and everything, notice my A, B, C, and D fall directly on my figure here, okay? So I'm going to go ahead, we're using our origin as our center, so there it is, okay? Now, you can see, like, if this patty paper moves, or this parchment paper moves, it's going to, you'll see that it's actually not, you can see that it's directly on there, right? So the first direction we're going to move is we're going to be moving, we can move clockwise if we wanted to. So the reason why we have multiple degrees in each box is because they're counter degrees of each other. So a full rotation in whatever direction, right? A full rotation, we should know, if those of you that skateboard or do BMX or anything like that, a full rotation is a 360, right? Half a rotation is a 180. 3/4 or, like, 3/4 of a rotation is 270. So when I rotate 90 degrees clockwise, okay, when I rotate 90 degrees clockwise, so I rotated that, it's special, like exactly right 90 degrees, right? So I took that, clockwise is this way. So if I rotate 90 degrees clockwise, my figure ends up right there in quadrant 4. This would be the same thing if I rotated 270 degrees counterclockwise. So 270 degrees means 3 quadrants, right? 390 degrees. So 270 counterclockwise, that's now this way, would mean here's one rotation, that's 90 degrees. So every 90 degrees, I'm rematching up my axes, right? So that's 90 degrees. Another 90 degrees counterclockwise, that's a total of 180. And then another 90 degrees counterclockwise, that's a total of 270. Notice how we ended up in the same spot, right? So if I'm rotating 90 degrees clockwise, that's the same thing as 270 degrees counterclockwise. 180 clockwise is the same thing as 180 counterclockwise, because it's 290 degrees in each direction. It essentially gets you to the same exact spot. Okay, so there's that one. And then if I'm back at my original here, we have that one there. Okay, so back at the original. Okay. And then of course you have the same vice versa here. So just like 90 degrees clockwise was 270 counterclockwise, 270 degrees clockwise is 90 degrees counterclockwise. Okay. And then of course 360 in each, it doesn't matter which way you turn 360, you're going to still end up at the same place. So here's a 360 turn clockwise, here's a 360 turn counterclockwise, right? So let's go ahead and take a look at our points here, okay? So if I take this and I want to rotate it 90 degrees clockwise, okay? I want to rotate this 90 degrees clockwise. So I'm going to take my figure, center, line up my X and Y axes. 90 degrees clockwise means I'm going this way here. So I turn this 90 degrees clockwise and I line up my axes again. So now my Y is on the X axis, my X is on the Y axis, okay, and my points are now in quadrant 4. So to get my points, my A prime, B prime, C prime, and D prime, I'm going to look at where these points fell, okay, where these points fell in quadrant 4. So we can see that A here, A ended up at this point here, okay, B is over here now, C is over here, and D is over there, okay? So when I take a look at these points, if I take a look at A, I can see that A is now at 8, -2. So I go 8 on the x-axis, down 2 on the y-axis. So A is at 8, -2. Okay. B is going to be at, if I take a look here, here's 5, here's 6, straight down. So 6, and then on the y-axis now, it's at a -9. So this one's going to be at a 6, -9. Okay, C, I see I only go 1 to the right, and then I'm going to go down 9. So this one's going to be at a 1, -9. And then D, of course, 1 to the right, down 2. So this one will be at 1, -2. Okay. So when I rotate 90 degrees clockwise and 270 degrees counterclockwise, I am seeing a change in my coordinates. Now, if I take a look and I compare my pre-image coordinates to this image coordinates of this rotation, I'm hopefully able to see a pattern. Okay. Hopefully I can see a pattern. We can see 8, 6, 1, 1 in our y coordinates in the pre-image, but now those have become our x coordinates. So our y coordinate, our original y coordinate, just became the x coordinate here. So that becomes y, okay? And then if we'll notice 2992, 2992, from our pre-image coordinates, that's our x coordinate. So that means that our x coordinate now became our y coordinate here. But not only that, these are all positive. They've now all changed their sign and become negative. So it's not just our x coming over, we're also changing our sign of our x. Okay, so we can see, so we want to generalize this, right? So we can say that when we rotate a figure 90 degrees clockwise, aka 270 degrees counterclockwise, okay, our rule is that our points at x comma y, they flip, okay, and then this coordinate here changes its sign, right? Notice I don't say it becomes negative, because this negative only means it's changing its sign. It doesn't necessarily have to be negative. If it originally starts negative, that means it's changing its sign, because a negative becomes a positive. Okay? All right. Hopefully you caught that. If not, please rewind the video, rewatch what we did, re-listen to it, okay, and see if that's going to help clear up the second time around. Okay? So we looked at our coordinates, compared it to our pre-image, and then found a pattern. Our x and y switched places, and then whatever came into this position changed its sign. Okay? All right. Next one on the list is a 180-degree rotation, counterclockwise and clockwise. So we're starting back at the original, okay? Every single time we're starting back at the original here. So now I'm going to go ahead and I'm going to rotate this 180 degrees clockwise and counterclockwise because they're the same thing. So I'm going to go 1, I'm going clockwise right now. So that's 90 degrees. I lined up my axes. That's 90 degrees. I'm going to do that one more time. Okay, 90 plus 90 is 180. So I have a 180-degree rotation, okay? And here's where my points end up. So if I take a look at these coordinates here, I can now see my A is down here, B is over here, C is over here, D is over here. I now want to write down these coordinates here. So my A looks to be at a -2 and a -8. Looks like A is at -2, -8. So 2 to the left, 8 down. So this is at -2, -8. Okay, I'm gonna have to zoom out there. Okay, my B looks like it's at a -9 here. All the way, here's my -10, so right before it, -9, and a -6 here. Okay, so -9 and -6. Okay, my C looks to be at a -9 and -1. Okay, and my D looks to be at a -2, -1. Okay, so there are my points there. Okay, so we're going to go ahead and we're going to compare these points now to our original pre-image points and try to see if we can come up with a general rule. Okay, so take a moment and think about it. Answer the question to see if you can identify what the rule is. Okay, all right. So hopefully you picked the correct one, but if you'll notice, my A starts off as 2, 8, and it ends as a -2, -8. B is a 9, 6, and ends at -9, -6. C is at 9, 1, and ends at -9, -1, and so on. So it looks like nothing is switching, but so my X and my Y are still in their original positions, but they've changed their signs. So they should have negatives in front of them because they're changing their signs. So that they started off as positive and they became negative. If they had started off as negative, they'd become positive. Okay. All right. Hopefully you were able to get that one. All right. So now if we go on to our 270 degrees 270 degrees clockwise, 90 degrees counterclockwise, okay? I'm taking my figure back to its original position here. Okay, back to its original position at its original ABCD. Okay, 90 degrees counterclockwise is a lot easier to get to, but I'm going to show you this 270 degrees clockwise. That would be 1, 2, 3, because there's 390 degrees and 270 degrees, okay? But if I had just done 90 degrees counterclockwise, starting back at my original position, counterclockwise is this way in the opposite direction of a clock. So if I just go 90 degrees this way, oh, look, I ended up in the same place. I'm going to line up my axes, make sure they're all lined up here, okay? And then again, I'm going to do the same exact thing with my points. I'm going to figure out where A is, where B is, where C is, and where D is here. Okay, so when we do this 90-degree counterclockwise and 270 degrees clockwise rotation, okay, when we do this, we are now dealing with, let's take a look at our points. It looks like for A, on the X here, we have a -8 and a +2. So I have -8 and a +2. Okay, for B, it looks like I have a -6 and a +9. Okay, I'm just looking at where my points are here, right? For C here, I'm looking at a -1 and a +9. So I have -1 and +9. And then for my D, I have a -1 and a +2. Okay. Okay. So if we take a look and we compare it to our points, see if you can determine the general general rule here. Okay, compare this column to the original column here. See if you can figure out that general rule there. Okay, answer that question for me. Okay, so let's take a look here. It looks like 2, 8 went to -8, 2. So it looks like we had a switch in our coordinates. And then it looks like our Y that went to our X now changed its sign. So this should have the new X coordinate should have a negative in front of it. Okay. All right, and then we have one more turn here. If I do a full 360 rotation here, oh, bam, right back on its original, right? So 360 counterclockwise. If I go 1, 2, 3, full 360 turn, full circle, I end up right back on my original figure here, which means my points are again at 2, 8. They are at 9, 6 for B. C is at 9, 1. And my D is at 2, 1, which means we went full circle and got back to our original X and Y. Okay, so these rules are incredibly important for you to remember, because when we do our examples, they're going to help us out significantly. Okay, they're going to help us out significantly. So let's take a look at some of our examples here. Okay, so this is the example worksheet that I have also attached to our notes here. I realized that I forgot to actually make copies of it and attach it. So I have attached it here. Okay. We will need more of our parchment paper. So if you have more of these, please go ahead and cut some more out. I just tore off like a sheet of it and I cut it into little squares here. Okay. So we're going to do some examples here. Now, notice over here it says rotation 180 degrees about the origin. Rotation 180 degrees about the origin. Rotation 90 degrees counterclockwise about the origin. Clockwise. And then we have another clockwise and we have another basic one. So wherever a direction has not been mentioned, we go back to our default direction of counterclockwise. Okay, we go back to our default direction of counterclockwise. So over here where it says rotation 180 degrees about the origin, well, we're doing counterclockwise. Okay, so this is going to be our counterclockwise rotation of C. Okay, so how are we going to make this easy on us? We can trace our X and Y here. So I'm going to show really quickly. I can trace my X and Y coordinate, my axes. Okay, and then I can, here's my X, here's my Y for my reference. And then I can do my points here. That one is, what is that? P? Random letters. K and N, right? So I can go ahead and trace my figure. So they want 180 degrees about the origin. So here's the origin. This is what I'm rotating around. So 180 degrees counterclockwise means I'm going this way. That's my counterclockwise way. So I'm going to go 1. Okay, line up my axes. Okay, and then 2. Sorry, now keeping my center very centered. Line up my axes and my center. Okay, so there's my new point. So F is right over here. P is right over here. K is right here. And N is right there. Okay, so I can find where they are underneath my patty paper and mark them. N is right here. So there we go. So this is a little bit difficult, right? Because it's like you have to make sure that you get the spot right underneath your paper here, your parchment paper, and then K seems to be right about there. So right there for K. So making sure that I got all the points correct here. It looks like I did. So that seems a little bit difficult. This is why we use our rule. Okay, so if we take a look at our rules, it says that if we are rotating 180 degrees counterclockwise, right? Then the rule says that I take each point and I give them opposite coordinate, or I give them opposite signs. So the rule here is that every xy then becomes negative x, negative y, or opposite x, opposite y. So if I use this rule, all I have to do is I just have to figure out what, I'm sorry, not A. Haha, we don't have an A here. I knew that. I just have to figure out what each of my points are here. So F, P, K, and n, figure out my points, and then use the rule to figure out what f prime, p prime, k prime, and n prime are going to be. Just like that. Okay, so I figure out, okay, so f is at 1, 2, 3, 4 to the left, so -4, and up 2, so up 2 there. Okay, p is at 1, and then 1, 2, 3, 4 up. K is at 1, 2, 3, comma 0, because I don't go up or down, so 3, comma 0. And then n is at -1, comma -2 here. Okay, so if those are my original points, my pre-image points, following this rule, okay, the negative, remember, means opposite. Okay, so this means opposite. So does that one, opposite. So if it starts positive, then it becomes negative. If it starts negative, then it becomes positive. So my x and y did not switch any places, so it's still x and y, but it's going to be opposite signs of what I'm starting with. So this is -4, so it's going to be a +4 now. This is a +2, so this is going to be a -2 now, because that's what my rule tells me, opposite signs. Okay, so if I look at my f prime, 4, comma -2, 1, 2, 3, 4, -2, there's my f prime, exactly where my parchment paper told me to rotate to. My p, it's +1, +4. So p prime will be the opposites of that. So -1 and -4. So here's p prime, -1, -4, right there. There's p prime. My k starts off at 3, comma 0. +3, +0. So -3 now and -0, but there's no such thing as a -0, so it's still 0. So k is at -3, 0, 1, 2, 3 to the left, right there. There's my k prime. Here's n, okay? N is at -1, -2. It starts off at -1, -2. So that means n prime is going to be the opposites of what I'm starting with. So if I start with -1, that means I have a +1 because it's an opposite. And then if I start with -2, that means I have a +2 because it's the opposite. So n prime is at 1, comma 2, +1 to the right, up 2, there's my n prime. So here is my rotated quadrilateral, right there. Okay. I want to leave this one for you guys to try on your own. Okay, so I want you to try this one on your own. At the end of the lesson, I will ask you to check your work. Okay, I will have it for you to check your work. Okay, let's take a look at number 3. It says rotation 90 degrees counterclockwise. Remember, counterclockwise means opposite of how the clock moves. So we're going that way. Okay, counterclockwise about the origin. So we're going 90 degrees here about the origin. So here's this. So here's my starting figure, my pre-image. That means I'm rotating this 90 degrees counterclockwise. Now I can grab another parchment paper and trace this, okay? And you can do that. There's nothing stopping you from doing that. I encourage you to do that if you are a visual person. I'm going to use my rule because I personally like using the rules. It makes it more mathematically easy for me. So I'm looking at 90 degrees counterclockwise. Looking at my rule set, 90 degrees counterclockwise, this is the guy right here. Okay, that's it right there. So I'm going to be doing 90 degrees counterclockwise right there. Here, I'll use purple. Okay, 90 degrees counterclockwise. So the rule is for 90 degrees counterclockwise is that each of my xy's go to -y, comma x. Okay, so every xy, oops, made the bubble. Okay, every xy goes to negative y comma x. Okay, that was our rule here, 90 degrees counterclockwise. What does that mean? Okay, so it starts off as xy and it becomes yx. So that means my y and my x are going to switch, but my y is going to also change its sign. Okay, so we start by figuring out what our bxn is. Okay, so point B, point X, and point N. We're going to start by figuring out what those are. Okay, so B is going to be at 1, 2, 3, 4 to the left. So that's negative 4, comma 1 up. So negative 4, 1. My X is right here. So that's going to be 1, 2, 3 to the left. So that's negative 3. And then 1, 2 down. So that's negative 2. Okay. And then N is at 1, 2, 3, 4, 5 to the left. So that's negative 5. And then 1, 2, 3, 4 down. So that's negative 4. Okay. Now I'm going to use my rule. Okay. My rule says to switch my x and y, but also change the sign of my y's. So I'm focusing on the signs of the y's, and I'm going to change it when I switch them. So my b prime, my x prime, and my n prime, okay, are going to be right there. And my b prime, so I'm going to flip the x and the y. So that means the y will come to the x position and the x will go to the y position. So since nothing really happens to the x other than that it now comes to the y side, I'm going to write those guys in right here. So that's going to be a negative 4, negative 3. Notice I'm not changing anything except its position here. Okay, so my x's now became my y's there. And then my y's are going to become my x's, but I'm going to change their sign. So this is a positive 1. That means that will be a negative 1. This is a negative 2. That means this will be a positive 2. This is a negative 4. That means it will now be a positive 4. Okay? So when I actually go ahead and I plot these points, b prime is at negative 1, negative 4. So negative 1, negative 4. Okay, there's b prime. My x prime is at 2, comma negative 3. So 2 to the right, down 3. This is now my x prime. And my n prime is at 4, comma negative 5. So 4, 1, 2, 3, 1, sorry, starting at 0, 1, 2, 3, 4 to the right, and down 5. 1, 2, 3, 4, 5. Okay, so this is going to be my n prime. So now when I connect my triangle here, okay, now you're like, well, Miss Kate, that doesn't look like it's been rotated 90 degrees. I encourage you to test it out. Okay, so here is my x and my y axis. Okay, x and y. Here's b. Here's x. Here's n. This is our original triangle. Okay, rotating it 90 degrees counterclockwise. That means we're going this way. So 90 degrees counterclockwise, matching up our origin here. Bam, right there. Perfectly falls on it. Okay. Perfectly falls on it. Okay. So this is essentially our examples, and I want you guys to continue on and complete these following examples here, and use the rules. And I'll have some questions at the end that you can answer to check to see if you've gotten them correct or not. Okay. Now to continue with our notes. Okay, we have something called rotational symmetry. Okay, and now rotational symmetry is when a figure can be mapped onto itself by rotation. by a rotation of 90 degrees, okay, or 180 degrees about the center of the figure, okay, about the center of the figure. So you rotate it with the center of the figure in mind, okay. A figure has rotational symmetry because of a rotation of 90 degrees or 180 degrees, maps the figure onto itself essentially, okay. So if I were to take one of these guys, and here's the center of my figure right there, and I'm going to trace this guy right there. Oops, sorry, you can't even see what I'm doing. My bad. Okay, so here's my center of the figure. I traced my figure. Now, if I do a 90 degrees counterclockwise rotation, right, I could even do a little axis for myself here. If I do a 90 degrees counterclockwise rotation right here, okay, does the figure map directly onto itself? Like, is it matching perfectly? No. So this parallelogram does not have, okay, does not have rotational symmetry. Okay. But then if I took this and I rotated it another 90 degrees, then it has a partial rotational symmetry, right? So, but it doesn't have rotational symmetry in general. However, if I took the octagon and I rotated it, you would essentially have more of a rotational symmetry, okay? So if I were to take this octagon, here's my center of the octagon, okay? And I trace this guy like this, like so, and I rotated it. Okay, see how it perfectly lands on itself? And then if I rotated it again, it would perfectly land on itself once more, and so on. Okay, so this regular octagon has rotational symmetry. Okay, I want you guys to go ahead and test out the trapezoid. Let me know, does it have rotational symmetry? Answer the question that's about to pop up. Okay. All right, so I'm going to go ahead and ask you guys a few questions about the rotations for numbers 2, 4, 5, and 6 on the practice sheet, okay? And please make sure you complete your exit slip and complete your homework. I wish you guys a great weekend. Be safe. I will see you guys on Monday. And we will be talking about dilations on Monday, all right? Have a great weekend, guys.